So let's see how much you actually know about solving polynomial equations. This is a tremendously important topic in algebra. And let's take a look at our problem. We have x cubed minus 2x squared plus 4x minus 8 is equal to 0. We are trying to solve for x. And this is a multiple choice question. So our answers are A, 1, 4, and I. B, 2 plus or minus 2i, or C, 5 and plus or minus 3i. Now, some of you might be saying, hey, Mr. YouTube Math Man, I'm really good at solving equations. Well, there's a big difference here in terms of solving equations, polynomial equations, because something as simple as 2x minus 1 is equal to 9, for example, is a basic polynomial equation. This is what we call a linear equation, and it's to the first power. So this equation is very easy to solve. Matter of fact, if we turn this x into a power of 2, made it a second degree polynomial equation, 2x squared minus 1 is equal to 9. This is pretty easy to solve as well. What we're dealing with here is a quadratic equation. So some of you might be saying, hey, Mr. YouTube Math Man, well, what's the big deal here? This is easy. This is x to the second power, but over here, we're jumping up one power from x to the second power to the highest power here being 3. Well, when you go from a second power polynomial to a third power polynomial or higher, things get very interesting pretty quickly. And I'm going to cover everything that you need to be thinking about in order to solve these type of equations. If you're taking any sort of math course like Algebra 2, College Algebra, Intermediate Algebra, Pre-Calculus, this is something, or this topic is tremendously important. You absolutely need to know a lot about polynomials. And of course, I'm going to cover everything that we need to really be thinking about in order to solve this problem. Okay, with all that being said, feel free to use a calculator. But if you can figure this out, go ahead and put your answer into the comment section. Then, of course, I'm going to walk through exactly how to solve this problem. And I'm going to kind of do a quick review of all the things that you need to be thinking about when you face a polynomial equation. This is really important stuff. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And if you need help learning math, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you just enjoy this content, make sure to like and subscribe, as that definitely helps me out. So let's have fun with this problem, but we have a lot to cover. And the great thing about this particular problem is it is a multiple choice question, all right? So some of you might be saying, hey, Mr. YouTube Math Man, I'm totally lost here. And what if I encountered this on a test? What could I do? Well, I suggest that you guess, right? So yes, indeed, I'm telling you, take a guess. I mean, what do you have to lose? Now, some exams, you actually do get penalized for getting a wrong answer. So you got to be very careful. But those are not too common. Matter of fact, tests like the SAT or ACT, you'll have to look at their policies. But typically, you do lose like a quarter point or an eighth of a point for wrong answers. But even so, in this particular case, you know, just take a guess, because most math teachers are not going to penalize you for guessing, right? But here in this situation, you can actually figure out the right answer if you know something about polynomial multiplication. Right now, here is what I'm talking about. So we know the correct answer is B. So what does this mean? Well, it means that we're solving for x. X is equal to 2, and x is equal to positive negative 2i. So that means x is equal to 2i, and then we have x is also equal to a negative 2i. So when we have a positive 2i and a negative 2i, we just write it as positive negative 2i. Okay, so we have three solutions here. Now, if you can think of these right here as linear factors, all right, so what am I talking about? So let's suppose you have a basic quadratic equation and your answer is x is equal to 4 and x is equal to 3. Okay, so these solutions from a quadratic equation would come from these two factors, x minus 4 and x minus 3 is equal to 0. So I can kind of reconstruct the quadratic equation here, right? So if I had two linear factors, x minus 4 and x minus 3, I would set each equal to 0, right? X minus 4 is equal to 0, and solve for x, so x is equal to 4. All right, so that would be one answer in this quadratic equation. Of course, we do the same thing with this other linear factor. So when you have solutions to a polynomial equation, you can just put those into linear factors and then just do all the multiplication and see what gets you back to the original equation. All right, so hopefully this makes sense. And to understand what I'm saying here, everything I'm going to be talking about, you need to be pretty familiar with solving quadratic equations. And of course, if you're not at this level of math, stick with me anyways, because you'll still be able to kind of learn this, even if it's for the first time. All right, so here is our solutions, right? So we could be like, all right, x is equal to 2, so that came from the linear factor x minus 2. And then here, 2i, I could go x minus 2i, and then I can go x minus a minus 2i right here. Now, I'm not going to do all the work, but what you could do is actually do all this multiplication, and it would get you back to the original equation. But that's a lot of work because you would have to actually test each one of those things. But another thing you could do, right, so this is one kind of approach. You could, and some of you are saying, hey, Mr. YouTube Math Man, you could do this as well. Indeed, you can. And if you're using your calculator, you have a lot of different ways you can figure this out. So if you look here, this equation has 1, right? I'm sorry, this choice has 1 as a possible solution to our equation, right? So this one has 2, and this one has 5. So we can kind of do a process of elimination by plugging in 1 for x, right? So some of you might be saying, hey, Mr. YouTube Math Man, that's easier. So if I go 1 cubed, I'll replace the x, and then I just kind of do this, right? Replace all the x's with 1. This is not going to work out, all right? I could just tell you right now, 1 cubed is what? That is going to be 1 minus 2 times 1 squared, so that's going to be 1 times 2, so that's minus 2 plus 4, right? 4 times 1 is 4, minus 8. Well, is all this going to be equal to 0? Well, no, we're going to get negative 1 here, negative 9, so all this is not going to add up to 0. So 1 is not a solution, so this cannot be right. Okay, now when you plug in 2, you'll see that positive 2 is a solution. You just don't know about these things here. But if 2 is a solution, well, it doesn't show up in this answer, so B is correct. So there's really no excuses for you to get this wrong. And I want to fully cover this problem because some of you that are taking or are still students and have to take math tests, I want to get you fully prepared so you can go in there and be like, all right, Mr. YouTube Math Man, I didn't really study, but hopefully, for my exam, but hopefully I'm going to have some multiple choice questions on my math test. And that is awesome. Sometimes your teachers, will put those in, but oftentimes they'll be like, no, I'm sorry. I just want to see what you really know. So solve this thing and, with no multiple choice options. So in this case, we're just simply going to have to do the math, and that's what we're going to get into right now. Okay, so here is our lovely equation. We are talking about polynomials. So I can say the word polynomials, but I suspect 3/4 of the math students out there cannot define what a polynomial is. Now, they might be saying, yeah, I know what a polynomial is, Mr. YouTube Math Man. I see it all, everywhere and all the time in my algebra course or math class. But what is a polynomial? Well, what we're dealing with here is a polynomial equation because not everything in math or in algebra is a polynomial. So it's very, very important that you understand what a polynomial is. Matter of fact, let me go up here real quick and just quickly define it in a rough kind of way. So let's just take a variable like x or y. It doesn't make a difference. You can actually have a combination of variables. We'll take a simple variable like x. Now, there's two parts to an algebraic term. Right now, for us, we're going to consider powers right up here, okay, or the exponent to this particular variable, and then we'll consider coefficients, what we can put in front of the x. All right, so let's just kind of settle this right now. So you could put, and we're talking about what a polynomial is here, right? We could put any real number we want in front of the x and it's still a polynomial. So I could put 3, or I could put negative 0.9, I could put pi, I could put 2/3. So you can have any coefficient in front of the x, no problem there. All right, so the real thing to be very careful about what a polynomial is the power, the exponent. So the exponent to on a variable, okay, like here on a base, can only be a positive integer or a whole number. So we're talking like 0, 1, 2, etc. So if you have something like x to the 1/2, this is not a polynomial, okay? This is not a polynomial. Matter of fact, this is equal to the square root of x. We're talking about a radical equation, okay? So that's something different than a polynomial, but if we have x to the, second power, that's a quadratic equation, that is a polynomial. Now, it's important that you know the difference between the two because I'm going to get into things that only apply to what a polynomial is. Now, even x to the 0 power is a polynomial, okay? So this is one term of a polynomial. We start stringing multiple terms together. Then you have binomials, trinomials, etc., etc. Okay, so I am covering a lot here, but just think by the time I finish this video, you're going to be like super smart in algebra, and that is the goal. So let's go ahead and continue on here. All right, now, if we look at our equation, we can see that all the exponents here are positive integers, whole numbers. So we got 3, that's good, 2. Here, this is x to the first, and then here, we have a constant, but really you can kind of think of this as x to the 0. Anything to the 0 power is 1, but that's not necessary. So we have a constant that is a polynomial as well. We can think of it as being in the polynomial classification, if you will. So we have an equation. All these monomials, these terms are polynomials, so the whole thing is a polynomial. That's really important. Again, if you had some sort of rational exponent up here, then what we're going to talk about does not apply. Okay, so we love polynomials for multiple reasons, and even in more advanced math like calculus, polynomials are awesome because we know a lot about them. All right, so we have a third degree polynomial equation. That's the highest power of this equation. So what do we know about solving polynomial equations? All right, so I'm going to get into this right now. So here are some things that we can think about, or we need to be thinking about, when we solve a polynomial equation. All right, so the first thing is the fundamental theorem of algebra, FTA, fundamental theorem of algebra. What does that say? Well, basically, the kind of short version of what the fundamental theorem of algebra states is that whatever the highest power of your polynomial equation is, that's how many solutions the polynomial will have. So we have a third degree polynomial equation, so we're going to have 3 solutions. So that's pretty awesome because now we know how many solutions we're looking for. But what type of solutions? Well, they could be real and or complex or imaginary, as we have in this case, right? So we have a positive 2, that's a real number, but then we have plus or minus 2i, which are imaginary numbers, which are part of the complex number system. Okay, now things that you study in basic algebra are like linear equations, kind of like these examples I was giving you at the beginning of this video, which are just basic equations. 2x is equal to 10. Now, well, this is a polynomial equation, but we kind of classify this as a linear equation. Then you move on to quadratic equations, and you learn a lot about solving quadratic equations, to include the quadratic formula, completing the square. I mean, this is a huge topic in and of itself. So we're talking about second degree polynomial equations. This has its own like a little world, right? So for those of you that have taken first year algebra, you know that there is quite a bit involved just even with solving quadratic equations. Now, one thing that can really help us is the graph of the polynomial. So if I gave you the graph of this particular polynomial, it gives us a ton of clues about where the solutions are at. Now, if you have a graphing calculator, you can plug this in and get some really good hints on where the solutions are at or what type of solutions. And so that's another kind of thing that you could use to help you solve polynomial equations, especially third degree and higher because it gets much more advanced. See, in a quadratic equation, we have the quadratic formula. Now, the quadratic formula will solve any quadratic equation. It's awesome. We have a formula that can solve any problem. Third degree, we don't have a quadratic equation type of formula that can solve this. So we're going to have to use all of our knowledge, and it gets much more complex. Okay, so these last two things are concepts or topics that you study when you get into more advanced algebra. So this is called the rational root theorem. We're going to talk about that later in this video. And this other thing is called the Descartes rules of signs. So there is a lot, and I'm even leaving some other stuff out. You know, again, this is a big topic in math. And if you're overwhelmed, I'm going to give you some suggestions on how you can really master this stuff. But again, we want to frame the problem. We're like, all right, we got a polynomial equation. I need to be thinking about all these things. So far we know, hey, we got it's a third degree. We're going to have 3 solutions. But we need a strategy to solve this, and that would be this. All right, so first of all, we know we have 3 roots. Now, sometimes you'll hear the word roots, zeros, solutions. They're pretty much the same. They're synonymous. So the roots, now there's little technical differences and stuff, but when you hear roots of a polynomial or zeros or solutions, again, these are pretty much the answer to the equations. All right, so we have 3 of them, but we just don't know if they're real or complex. Now, it would be nice to have the graph. And if you're pretty good at graphing, we could literally graph this polynomial. Now, that would be a problem in and of itself if we don't have a calculator, but we could construct it and get an idea of what type of roots and where those roots are at, these solutions. But the best thing to do here is to start with the rational root theorem, okay? This is our kind of main starting point. So when you are faced with these type of problems in your algebra class or your math class, your teacher is going to want you to start thinking about the rational root theorem. Okay, so I'm going to get into this right now, so let's get going to the next step. I know I'm talking about a lot of things, but just imagine how much smarter you're going to be when this video is done. All right, so we are going to get into the rational root theorem. Now, before I even start, okay, what is the rational root theorem? All right, now a rational root, okay, let me go back over here because I really want you to understand this concept. All right, so we have to go back to what is a rational number. Okay, so on a real number line, here's 0, here's 1, here's 2, here's 3, and any number that is like 1/2, any number that we can express as a fraction, okay, of integers is a rational number. So, for example, 1/2 is a rational number. -3/2 is a rational number. 2 is a rational number because we can express 2 as 2 over 1. Now remember, a rational number is where the numerator and denominator are integers. Okay, so we're talking about positive and negative fractions and positive and negative numbers like over here, -5 or 3. These will all fall under the classification of rational numbers. So these type of numbers, okay, when we're looking for the solutions to this equation, this solution may have rational roots. In other words, rational answers. In other words, maybe one of the solutions here is 2. Now, of course, we already know that's the case, but maybe another one is like 1/2, and maybe another one is -3/2. These are rational roots, but you can have other type of solutions here. You can have like x is equal to the square root of 7, okay, or positive -7. This is not a rational root, but it could be a solution. So the rational root theorem, okay, is a way for us to list out all the possible rational roots that this equation may have. May, I have to kind of stress this, may have, all right? We don't know if it has rational roots, but if it does, it's going to be part of this list that we're going to construct. Okay, so let's go ahead and get into this right now. So what we need to do first is list our polynomial from highest to lowest power. So third degree to 8, this is what we call standard form. Now, the leading coefficient here, we're going to label that as Q, and then our number over here, we're going to label that as P. Okay, so here is the rational root theorem. So it basically says the factors of P, okay, which is the constant value right over here. In this case, it's -8. over the factors of q. And in this particular problem, the factors of q is 1, right? So that's 1. So we're going to list all the factors of p and q, and we're going to create a fraction. This is a fraction, right? So the factors of p over the factors of q. So this is 8 and this is 1. Doesn't make a difference if it's negative or positive. We're going to still have the same factors. Okay, so what are factors of 8? Well, positive and negative 1, okay? Because negative 1 and times negative 8 can get us to a negative 1 times negative 8 gets us to a positive 8, or negative 1 times a positive 8 gets us to a negative 8. So just what you want to do, it's always going to be positive and negative, right? I'm kind of speeding up here because explaining the rational root theorem is like a full lesson in and of itself. So we're going to pick up the pace here. All right, so again, whatever this number is, you're going to just start listing out the factors of 8. So you're like, all right, well, 1 is a factor of 8, 2 is a factor of 8, 4 is a factor of 8, and 8 is a factor of 8. So we're going to list them with positive and negatives, just like this, okay? Now, factors of 1, pretty easy. That is just 1, so positive, negative 1. All right, so this is a fraction. Now, what we're going to do is take every possible iteration of the numerator and denominator. So 1 divided by 1, positive, negative 1 divided by positive, negative 1 is what? Well, that's going to be a 1, right? 1 divided by 1. 2 divided by this 1 is 2, okay, positive, negative. 4 divided by 1 is going to be 4. And 8 divided by 1 is going to be 8. All right, so no problem there. Now, here, okay, you can see we have a list. Okay, so we just kind of basically divided this denominator by all these possible numerators. Now we have this lovely list. This is what we worked so hard for. And this list is the possible rational roots. Okay, let me say this in a different way. If our equation here has a rational root, okay, or rational roots, it will be among these numbers right here. In other words, we're not going to have like 2/3 or 5 because that's not on this list. So here we have possible solutions, okay, at least one or maybe two or maybe all of them amongst this list. So we need to start testing these possible rational roots in the hope that we actually have a rational root, because that's going to allow us to solve the rest of the equation. All right, so let's go ahead and start doing that right now. So here is our list, and this is going to bring us to another lovely topic called synthetic division. Now, I know a lot of you at this point are like, Mr. YouTube Math Man, I'm done, I quit, my hair is just on my ears. Now, before we continue on, if you want to get better at math, you definitely can. But the key is to find a teacher that gives you clear and understandable instruction. So hopefully you like my teaching style. And if you do, if you're like, yes, I think I can learn from you, well, then you will love my full main math courses. So you can find the links to all of these courses in the description, but they include basic math, pre-algebra, algebra 1, geometry, algebra 2, pre-calculus, and a ton of specialized test prep math courses. Okay, so again, don't give up if you're having a tough time in math. I can definitely help you out. So you can check out the links to all these courses in the description. So let's get back to the video. I got smoke coming out here. Well, listen, take it easy, take it easy. We're going to get through this one step at a time. But what we want to do is test these solutions to see if, in fact, they are good. Now, you could plug them in, as I described. We can take this one and plug them in right here, but that is not the most efficient way to do this testing, okay? What we want to do is we want to do something called synthetic division, and this is another big topic that involves a polynomial long division, and this is kind of a shortcut. So I'm going to show you this. This is going to be pretty cool here, and hopefully most of you watching this video have studied this before, so you kind of know what I'm doing. All right, so here is our polynomial. Now notice we have the coefficients here, 1, -2, 4, and -8. Our polynomial must be written in standard form, and all terms must be represented. In other words, we can't go from x cubed to x. We need to, if we're missing an x squared, we just put in a 0x squared, okay? All right, so again, I'm covering a lot of territory. So what we're going to do is write these coefficients just like this: 1, -2, 4, -8, right? So they're coming from these coefficients right here. And then we're going to draw this lovely kind of L bracket like so. All right, so this is the setup for synthetic division. All right, so now let's go ahead and start testing some of these solutions. Now, let's start right here. We have positive and -1. Let's test to see if 1 is a solution. So this is how it works. So we're testing 1, and I'm going to show you the process right now. Okay, so what we're going to do is take this first number, okay, in this setup, and we're going to drop it down here. In this case, it's 1. Okay, so we're going to take this 1, and we're going to drop it down here. Okay, so whatever this number is, you're going to write it right down here. Now, I already did the problem, but I'll repeat this in a second, and in real time, so you'll see. So you're going to take 1 times this 1. Okay, 1 times 1 is what? 1. You put your answer right there. Okay, now you're going to add down. -2 plus 1 is what? -1. -2 plus this positive 1, -1. Now we're going to repeat the process. 1 times -1 is what? -1. Now we're going to add down. 4 plus -1 is a positive 3. Now we're going to repeat the process. 1 times 3 is 3. And then we're going to add down. -8 plus 3 is -5. This is what we call the remainder, okay? Now, notice we have -5 here, right? Well, that tells us that 1 is not a solution. What we're looking for is our remainder to be 0. If our remainder is 0, then this number is a root. It is a solution. So we're going to use synthetic division to test these values, okay? So what you would do is you just start going through your list here. So we'll test 1 and -1. I'm not going to test -1 because that's not a solution, but 2 is a solution, right? Because I already told you the answer. So let's see how that works. All right, so we go through our list and we're like, all right, 1 is not a good solution. So we move on to -1, then we try 2, we move on to -2. It's a lot of work. Yes, I know it is. But anyways, let's go ahead and continue on. And let's test 2 because we know that does work. So let's see how this plays out. Okay, so here's 1. We're going to drop it down just as I indicated. And now we're going to start the process. 2 times 1 is what? 2. Okay, we're going to add down. -2 plus 2 is 0. All right, so 2 times 0 now is 0. Okay, we're going to add down. 4 plus 0 is 4. And then 2 times 4 is 8. -8 plus 8 is 0. All right, awesome. 2 is a solution, okay, because 0 is a remainder. Now we can take the next step to figure out the rest of the solutions to this polynomial equation. So we tested 2, and we have the remainder 0, so 2 is good. Now what does that mean? Well, here, remember, 1 was the coefficient for x cubed, and -2 was the coefficient for x squared, and then we have plus 4x, and then -8, right? So that was our equation. Now, this is the way it works when you're doing synthetic division. These right here, this 1 is our x cubed, this is our x squared, this is our x, and this is our 8. These numbers are on that, these are the respective degrees. Now, our answer down here drops down 1 degree. So if this is x cubed, our answer down here is x squared, okay? And so instead of an x, this is now a number. I know this is confusing because I'm trying to cover a lot of territory quickly, but we know that x is equal to 2 is a solution. So now what we have is 1x squared plus 4 as a remaining linear factor, okay? So in other words, we can literally write this as 1x squared plus 4 times x minus 2 because we know that 2 is a solution, right? If we set this equal to 0. Remember, this whole equation is equal to 0. We got x is equal to 2, okay? So that's pretty awesome. So this is the other linear factor. So now we have 1x squared plus 4, and now we just need to solve this to find our other 2 solutions. Remember, we have three solutions here. All right, so we're going to set x squared plus 4 equal to 0 and solve. So we're going to subtract 4 from both sides of the equation. We get x squared is equal to -4. So we're going to solve this lovely quadratic equation by taking the square root of both sides. And when we do that, we're going to take the square root of -4, which, of course, is an imaginary number. That's going to be equal to positive -2i. Hopefully, you understand what's going on here. And again, these are two unique solutions. Okay, so our three specific solutions is 2, okay, which is a real number, rational root, and then we have positive 2i and negative 2i. Here's our three solutions per the fundamental theorem of algebra. And I know some of you are exacerbated by this. You're just like, Mr. YouTube Math Man, boy, well, maybe you're saying this. Thank you so much. I finally get it, okay? Well, I hope that's the case. I covered a lot of material, okay? Pretty much did multiple chapters of algebra in this one video, but sometimes it's good to kind of see the summary of where things are at. But this is stuff that you need to know at this level of math, right? Unfortunately, there's no way of getting around it. But if you need help in this, okay, make sure you get it either from myself or from someone else, because it's only going to get more challenging, again, if you plan on continuing on in math, and I hope you do. All right, so with all that being said, I definitely wish you all the best in your math adventures. Thank you for your time, and have a great day.